let me just Mara, your teacher in a experience liyaku ikhala creator future ya South Africa. And that, yeah, that is good. Like if no one is joining, I ingena in a na lava na theorem liya ikalika yo is una kokala.
Okay.
I going once, going twice, they are not joining us. Okay, let me do this and then we start.
Simplified, or a set of guys who makes it looks easy. Your number one learning channel. Ooh. Ooh.
Look, under Mr. Smith, this is how it was supposed to start every day. Mara ntsundzuka every time. Ntsundzuka khale ku oka big na pattern liya. The kind of original Mr. Smith, I fucking sunguna like that all the time. They will plummet me. But anyway, unlike Shara screen, I was never meant to play that one. So unlike Talanwa. Okay. Wana lanwa, lava ihlamusela na theorem lewa iveyu makayo once and for all. Although for this thing, you're gonna apply this for your final, on your final exam, probably next year. But for now, it's just for the sake of knowing the theorem, where it comes from, how it works, and what are we proving. So, fortunate enough for questions where ufekele prove something, sometimes students have a way to say, you know what? If I have to prove a theorem, I don't have to stress. I can memorize the proof. You know, like memorizing proof, just like memorizing any other equation or memorizing any other theorem. Here's the thing.
Yeah.
Long time ago, for yina I tamatula mahashine, long time ago, I rena stress shaku. We didn't know how to speak English and we didn't understand English. And the problem was school required English because I just hey, like, you know, the reason why people were dropping out is because the language, bruh. Like you can't ask me questions about photosynthesis, and then you explain to me what photosynthesis is in English. While I don't even understand the word of what you are saying, such that even if you transfer to my language, interpret, like it would be that thing you go, ay. So school was hard because language, but for you guys, it gets easier and easier because the language is not an issue anymore. Maybe like you are at a state where Shilungu, I big deal that much. I mean, part of life because it's just you should have every now and then. And the in TV, I develop such that if you were to watch cartoons, I'll accept ku utahleki blind. Maka swa ku unavubarunyana like ubukela Popeye, like you know. So people like us who were the victims that hlekiwa ku I bukela Popeye. Like that's that even your nickname, what gonna we Popeye. So so utiveka endlela hi swilo swa ku hi community a swi nga ri kahle mara as long as swa ku man, for me I'm doing it for me, like people didn't understand how it was like futhi and I wanna Dragon Ball Z because vanhu va face ti-cartoon ta minkarhi ya hina va tirhisa Dragon Ball Z handle ka Dragon Ball Z a ku ri na some cartoon shows ta ku u gqina u vona ku nga ku I'm the only one who's watching this loko ringeta ku initiate a conversation na vanghana va le xikolweni u vona ku hayi demands a va tivi nchumu and minkarhi ya hina phela a ku ri na 4 channels ntsena a wu yimela 4:30 3 man. So because of that language, it messed up everything. Same applies with mathematics. You see mathematics, like sometimes, like I say, like we said earlier, and Mr. Smith always unsupported. It's not really about the grade. It's not really about um it's actually just a language. Like mathematics in a language here's a story. You can memorize something without even knowing what you are saying. Like just by memorizing it. Like a lot of people would come up with a way where before you eat, they would teach you how to pray before you eat, and you would pray in English, or God bless our food before we eat, amen. For a child, if you teach that prayer to a child, they only would understand what that prayer means maybe later on. For them, it's just a thing you say before you eat. That's memorizing. At some point when I was younger, my favorite song was Barry White, Practice What You Preach. I'm telling you this, I'm in primary school, probably doing grade 4. The reason why that became my favorite song is because Kamungana Lonene, they would play that song over and over. I didn't know what they were saying, but I loved the tune and the way they're singing. To a point where I could sing the song. I could sing through Nabova White at that time. And like my parents were so proud, like, but I didn't even understand what was going on. I was just memorizing, mimicking the very same words they're saying. Till later on, 10, 15 years later, I'm like, wait, that's I read deep so. And I'm like, the child, I didn't even understand it. So same applies with mathematics. For now, you are just memorizing things, and then you're gonna probably start a career, whether you become an engineer or a doctor or even a mathematician. And then you're gonna ask yourself, like, damn, the entire time I've been thinking, I mean, this thing is like just as simple as this, or it works like this. So that's why I'm like, without even having to memorize, we just want to be applying properly. So now you will have to, okay, we have a new member now. Ntalimitanyana ka Xitsonga ne.
Okay.
Like take a volume nyana ni isa like low ka Xitsonga. So more English. Hi Kanya, how are you? Can you hear us? Is your sound fine? Hello, hello, hello. Okay, I hope she can hear us. I don't know what's going on. But anyway, now, so you get this date, and then at some point, you get marks by proving something. When you have to, okay, besides the memorizing part of it, let's look at what they are saying. In diagram below, O is the center of the circle passing through PQR. chord PQ. Okay, cool. So from the picture that you sent me, Jade, the one you sent me, where is the chord, where is the diameter, where is the what. That is very important to digest that information, ne?
Yeah.
More especially to understand the difference between a chord and the diameter. And like the difference between a chord, a diameter, and a tangent. On a second. So this is how it goes. With the chord, I'm just gonna do the summary on the side. With the chord, so from a circle must always have a center O. So with the chord, a chord is just any line that goes from one circumference to the other circumference. That's just a chord. And then a diameter, it's more like a chord that passes through the center. So if it passes through the center, it now becomes a diameter. And the diameter, we know it's made up of two radiuses, right?
Yeah.
And then outside, a chord doesn't go inside. It just touches from the outside. It passes like that. It touches one point only. That's a tangent. So a chord, a diameter, and a tangent, knowing the difference will save your life in so many events under Euclidean geometry. Now, in the diagram below, chord PQ and PR are drawn. We can see chord PQ and PR that are drawn with OQ and with OQ and OR joined. We can see the OQ and OR being joined. And outside of this question, OQ and OR, somehow they form radiuses. Do you see that?
Yeah.
So if in another event would know that OQ and OR have to be equal, even if it was not told, we can tell that because they are all from the center to the circumference, which represents the radius, but not involved in the story of what we are doing here. Use the diagram provided in answer sheet to provide the theorem that states that the angle subtended by an arc at the center of a circle is double the size of the angle subtended by the same arc at the circle. So the arc that we are referring to is this arc. So this arc formed this angle.
What's the difference between an arc and a major arc?
Major arc would be, if I define it as it is, major arc would be the one that displays the one, like, I would say in this regard, if I'm talking about that arc, then the major arc would be the bigger one that displays more circumference than the other. In this regard, it would be our major arc, that one. I'm gonna do my research as to what exactly are you asking me, but I'm just thinking, I'm improvising with my answer right now. So I'll get back to that. Let me confirm it properly before I tell you that don't exist. But now, in terms of this arc, it forms that angle, which is this angle. But then the very same arc forms another angle. Starting from the same point, which is this angle. So we say that if this angle is 2x, this angle would be x, because the angle at center, or the angle subtended by an arc at the center of an angle, is double the size of the angle subtended by the same arc at the center of the angle. That is, we must prove ROQ. We must prove that ROQ is equals to 2p. ROQ is double p. So how do we do that? To prove, this is what you do. The first thing you do, you're going to construct a line from here. You construct a line starting from P. And then you go like that. Because you want to talk about P and O. But when you get to O, you don't just stop there. You have to extend your line a bit. The reason why we extend our line a bit, because we want it to form angles here and here, because we want to talk about those angles. So after that, we're going to call this our O1. We're going to call this our O2. And then we're going to call this one our P1. And then we're going to call this one our P2. That's the first step of proving this theorem, that construction. And then from here, we know that in geometry, we don't just say what we want to say. We must state a statement and a reason why we are saying that all the time. So before we prove, we prepare to state a statement and a reason. Right. So if you learn such things for the first time in day one, it's going to seem like it's new to you. In day two, you repeat the same thing. In day three, you repeat the same thing. In day four, you repeat the same thing. You'll see that proving actually is just the same thing, which is the reason why other people memorize it the night before exam. Mara, people who normally memorize it, you know, they're going to do bad on the paper, because how do you memorize something which you're going to apply after? And in reality, the way it works, every time 9.1 says prove this theorem, 9.2 is usually a case where you have to apply that theorem that you are proving. But in terms of this, let's look at this. Number one, I will say construct PO and extend the line. That's the statement. That's the first thing I did. I constructed PO and extend. There's no need to give a reason for it as such, but if I was to give a reason, I would say construction. Because that's the first thing I did. Do you get that?
Yes.
Yes.
And then from here, yes. Oh, I didn't see. Now we have a full house, more or less. Hi, Musidi, how are you? Very good. Kanya, is your mic better now?
Yeah, it's better now.
All right. Are you comprehending? So far, you are with us in everything that we've done, eh?
Yes.
Okay. So, the story goes now. If you look at, remember our goal, we don't lose our goal. Our goal is to prove QOR to be equals to 2P. QOR to be equals to 2P. Now, I have to focus on those angles. So my opening statement is that angle Q plus, oh, no. I will first say in triangle QOP. In triangle QOP, angle Q plus angle P1 is equals to angle O1. Do you all agree? Or does anyone agrees or not sure or whatever? Let me write it like this actually, from left to right. O1, angle O1, look at this properly. Angle O1 is equals to angle Q plus angle P1. Before I write the reason, do you guys see why do I say that? That this angle plus this angle is equals to this angle.
Is it because it's the exterior angle of a triangle?
Exterior angle of a triangle in triangle QOP. So we'll then say the reason is exterior angle of a triangle. Everyone, we do get that part, ne?
Yes, we do.
But if I was to say to you, angle O1, no, I will come to that one. If I was to say to you, angle P1 is actually equals to angle Q, would you agree?
Yes.
Why are they equal?
Angles opposite equal sides.
Yes, angles opposite equal sides, because triangle QOP is actually isosceles triangle. And then OP is equals to OQ because they are radiuses. So this side of the triangle is equals to that side of the triangle, which forms isosceles triangle, which makes this angle to be equals to that angle in those triangle. So if that's the case, then okay, now I write the reason for that. Opposite angles of opposite sides. So you can even say isosceles triangle. If you are lazy, you will still get the mark. So look now, O1 is equals to P1 plus P1. Do you agree? My reason is going to be the fact that P is equals to Q. P1 is equals to Q. So where there's Q, I just substitute P1. I haven't lost anyone, right?
No.
All right. So therefore, angle O1 is equals to 2P1. Angle O1 is equals to 2P1, specifically for that triangle. Now, in extension, remember this is 6 marks. The proof is 6 marks, so meaning we must work nyana for it. And then as it goes forward, we're gonna then have we know we can't run away from the fact that we must give every statement with a reason. If the statement doesn't have a reason, you don't get a mark for it. Now, we are moving to the other side. Now, look at this. I will say, in triangle ROP, angle O2 is equals to angle R plus angle P2. Same reason, exterior angle of a triangle. Again, angle R is equals to angle P2. Reason being isosceles triangle. And then angle O2 is going to be P2 plus P2, which makes O2 to be equals to 2P2. Interesting, right? So I have O1 equals to 2P1. I have O2 equals to 2P2. So look, I have O1 equals to 2P1. I have O2 equals to 2P2. And then I ask myself, since O1 and O2 are composed of the same angle, since O1 and O2 are composed of the same angle, what happens when I add angle O1, when I consider the whole angle as a whole? So it's going to be O1 plus O2. Angle O1 plus O2, I'm talking about this angle plus this angle. So O1 plus O2 is this whole angle. So O1 plus O2 is going to be equals to 2P1 plus 2P2. I just did the maths there because they are all equals to 2P1 and 2P2. So I just substituted the other side with the other side. But to make this more easier, angle O1 plus angle O2 is going to be equals to, if I take a common factor out of 2, I would have P1 plus P2. But what is P1 plus P2? P1 plus P2 is your angle P, right? P1 plus P2 is your angle P. What is O1 plus O2? O1 plus O2 is your angle QOR. Let me write that statement. Let me write this statement up here because where it's hidden, it doesn't make sense. I'm going to write this. I say O1 plus O2 is equals to 2P1 plus P2. But I constructed that thing myself. I constructed P1 and P2 myself. Actually, P1 and P2 forms angle P entirely. Do you see that? And then
Yes.
O1 plus O2 forms what I should call Q or ROQ. ROQ. Because here is O1 plus O2, which is ROQ. So you are done with your proof. There you go. Question is this challenging?
No.
No.
And the nice thing about it is when you get it on an exam and you have to prove, you repeat it exactly as it is all the time. So once you prove it once, you prove it 2 times, you prove it 5 times in the form of practice. There is no way you can walk inside an exam and not get anything correct there. And remember, for every proof follows the application. For every proof follows the application. So we know that the next question should have that story somewhere. It might not be directly as the shape, but remember that this angle, before I even go on the next one, remember that this angle can be it can be represented in different forms as long as it's angle at center that forms something. Because look at this, I can have a circle. My circles, they don't want a circle, but yeah. Now, if I have this arc, okay, see, it has a center here. If I have this arc forming that, and the very same arc goes to the circumference and forms another angle there. So it doesn't always has to be in that shape. This rule would still apply that angle at center will be twice the angle at the circumference. Sometimes it may be that I have a circle and then I have a diameter. After I have a diameter, the diameter forms an angle there. And then the diameter is there. And then we call this A, B, C. Normally, for you guys who knows, what would be the value of angle C?
Would be 90 degrees.
It would be
90 degrees.
90 degrees. Very good. And your reason would be?
Angles in a semicircle.
Angles in a semicircle. Very good. I'm interested that you brought that up. So now look at this. Angles in a semicircle, according to the rules of angle in a semicircle, this would be 90 degrees. But let's use this rule of angle at center is twice the angle at the circumference. So let's consider this our circumference. So this is going to be our circumference, and then it created an angle at center, which is 980 degrees because it's a straight line, right? So since it created 90 degrees with this, and then the very same arc formed another angle. Now that angle will be half the angle at center. So without using the rule of angles at the semicircle, I can use this rule to say this angle is 90 because this one is 8 and that one has to be half of this. Do you get that?
Yes.
There are many ways to kill. There are many ways to kill a cat in mathematics. So some of those rules they're gonna form alternative solutions for you. So the reason why, remember I said, if question 1 is about you proving something, question 2, you are more likely to apply what you are proving. So to support what I was saying, let's go to the next question and see. So it doesn't necessarily, we just know at some point this rule might play a role. It doesn't necessarily have to be this shape exactly. You just have to know how it works. Now, let's see the story. So in the diagram below, DF is a diameter. So DF happened to be the diameter of the circle with center O. Chord EG. Chord EG, you look at the chord, intersects DF at H. We can see that such that DF is perpendicular to EG. Chord EF and GF are drawn. Chord EF and GF are drawn. Angle EGF. Angle EGF is 55 degrees. For sure, you can see some of the theorems here outside of this one as well. Now, let's look at this. First of all, with statement and a reason, we have to answer for ourselves what would be angle D. Does anyone see how we're gonna put angle D there?
Would it not be 55?
D.
55, okay? What's the reason?
Angles in the same segment?
Angles in the semicircle.
Angles in the same segment.
Or angles in the same segment.
Mm.
Okay. For this one, we may not have spoken about the rule, but I can see where some of you are looking at it. That's what you are looking at then, where if you have a shape like that, and then these angles are equal. Is it what you said? Is that what you applied? Okay, is there anyone who doesn't support D being 55 before we move on? We are just having a mathematical conversation. Okay, what about O2? I'm gonna do this as we answer, so we can put it properly with our statement and reason. So we said angle D is equals to 55 degrees. Angles in the same segment. Then what about O2, angle O2?
It's 110.
Very good, 110. Does everyone agree?
Yes.
Great. Musiri, do you agree?
Yes, one.
Right. Why is O2 110?
Angle at the center is 2 times angle at the circumference.
Aha. So you managed to see that shape. So from there, we know that if this angle is 2x, that one will just gonna be x. So if this angle is 55, this one will be double that, which will be 110. Very, very good on spotting that. So that's how basically we apply these theorems, guys. Just like this. What would be the size of E2? Angle E2. Let me put it here. You're not seeing the E2 one, eh? Let me give you a hint. If you know O2, you can know O1, right?
Yes.
So what would be O1?
70 degrees.
O1 is 70 degrees. Reason, angles in a straight
Mm.
line. Very good. Now, if O1 is 70 degrees, you have 70 degrees. You do know what H2 is, right?
Yes.
90 degrees, Angel. So
Yeah.
what would be E2 now? E2 is going to be 108 minus 70 minus 90. Therefore, E2 is going to be
20 degrees.
20 degrees. Actually, that statement about E2, if I'm writing it properly, I should have started by saying 70 degrees plus 90 degrees plus E2 plus angle E2 is equals to 180 degrees. The reason being angles in a triangle. Because what matters is to put your statement and reason. So E2 would be 20 degrees like that. So for a question like this, guys, you just have to be like, there's no, like for geometry, you are not applying, you don't have to be smart, like crazy smart. You are just working around like it's like you are playing hide and seek with angles and variables. You are trying to see where did they hide this one. The last question is to find the value of E3. This is going to be our last one for this one. E3. Okay, before we found E3, let me label the ones that we have already. We have this one is 110. We have this one is 70. We have this one is 20 degrees. We have this one is 55 degrees. With that information, we can tell the value of E1, right?
Yes, sir.
E1 will be
45.
E1 will be 35 because angles, the sum of angles in a triangle. 35, sum of angles in a triangle. Now, with that information, then what would be E1?
Also, wait,
Also,
E2,
hmm?
the mean E3.
E2 was 20 degrees. Remember we found E2 on the previous. This was our E2. But all you know when is that E1 plus E2 plus E3 must give you what?
90 degrees.
Very good, 90 degrees. And then now you know that you can give two reasons. You can say angle at center, or you can say angle formed by a semicircle. So that means E1 is gonna be, E3 is gonna be 90 degrees minus 35 minus 20, which will be
35 degrees.
35 degrees, which makes that to be 35. So whatever they come, even if they can say find F1 or F2, now you are good to find every angle that you need. But do you see, like, look, with this part, all we need to do is to remember as many reasons as we can. There's more to this. Sometimes inside the circle, you're gonna have parallel lines. Some of these parallel lines, they're gonna have a line passing through the parallel lines. And then you will remember like, oh no, if I have that situation, I'm gonna have them alternating angles, them corresponding angles. Sometimes on that circle, they just hold a random two triangles that may be even similar. So you just apply your similarities inside there. And look, all we need is just practice, 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 and then we'll get right. So I think for this one, just for the sake of, I want to do another lesson. For this one, we can call it a day for now. I will let you know, guys, if we can proceed with other ones. I'll talk to you based on groups by groups, but I know for some of you get tired or some of you are doing these ones off, but it's a Saturday. So for me, on my side, remember, I fall under the group of people who don't really have lives. So I just sit here and talk to you, talk to you guys different from this one to this one. So yeah, I'll let you know when we proceed on the other side. Thanks for your time. Enjoy the Saturday that you are having so far until we talk again. Cheers, bye. You can get off
Bye.
the link for now until I tell you to come back again. Thank you.
Okay.
If you are watching this from YouTube, just know that you can be part of our group. We don't have limits. We learn every day. Just that we broadcast 1 or 2 streams every once in a while, but generally we learn every day. Weekends we learn throughout the day. During the week we learn in the evening after school throughout the whole entire evening. However, if you want to join us and be part of us, feel free to WhatsApp the number 082. No. The number is 081 465 2676. That's 081 465 2676 to inquire about our private lessons. But in addition to that, you can also send me whatever question you'd want us to discuss, because I do make pre-recorded videos which I put on our YouTube channel. And also don't forget to subscribe on the channel. And do press that reminder button so you do get to be notified whenever we go live like this. I am Mr. Maimane. This is Simplified RSA. We are the guys who make it look easy. And this is the outro.
Simplified RSA, the guys who makes it looks easy. Your number one learning channel.